Hello everybody, this is Jonathan. In this video, I'm going to be showing you the worksheet and my solutions to the worksheet. So let's just get into that and I'll just show you my process into doing this worksheet. So what I'm going to do is I'm going to share my screen. And we are going to go into here. I have the worksheet already here, and we're just gonna fill it out like as we see fit. So name, obviously, let's change my brush really quick. Layer 2. So name, obviously, that's very important. So we're just going to go through 3 basic topics, which are solve trigonometric equations, use the law of sines, and using the law of cosines. So let's look at this first problem. A man whose eyes are 1.7 meters above the ground looks up at a 78-degree angle at a light post. If the horizontal distance is 2.4 meters, how tall is the lamp post? Okay, so what we're given here already is a right triangle, which is starting 1.7 meters above the ground. Keep that in mind. So we have a triangle that looks kind of like this. 78 degrees. And this is 2.4 meters. And so we know that tangent is opposite over adjacent. So tangent of 78 degrees equals opposite over 2.4. Multiply both sides by 2.4. We get 2.4 tangent 78 degrees is equal to 12.7 meters. However, this is not done. This is not the last step. So because in the beginning, we're told that his eyes are already 1.7 meters above the ground, and that's our point of reference. So we add the 1.7 meters. We get our final result of 14.4 meters. So just keep that in mind, read through the whole question thoroughly, and just being able to realize like, oh, it starts 1.7 meters above the ground, and just find all these key points so that you can solve the problems. Okay, question number 2. A little girl is looking out her bedroom window, sees a hotel across the street. She looks down at a 14-degree angle to see the bottom of the hotel. She looks up at a 40-degree angle to look at the top of the hotel. If the horizontal distance is 60 yards, how tall is the building? So we're given 2 right triangles here. So we're just going to use that information and just get going with it. I would convert this 60 yards into feet. As we know, 3 feet is a yard, so we end up with 180 feet. So we have the first part of our problem, which is tangent of 40 is equal to opposite over 180. So opposite is equal to 180 tangent 40 degrees. And for these types of problems, make sure your calculator isn't in radian mode, otherwise you're going to get something completely different. So what we end up with is about 151 feet. So and then that's just one of the two triangles that is made up. So let's look at this second triangle, which is tangent 14 degrees. I'm sure we have this degree symbol on there, is equal to opposite over 180 feet, feet. And then you do the same process, dot, 180 tangent 14 degrees, and that's approximately 44.8 0.9 feet. Add these together and you get your final hotel height, which is 195.9 feet. Now I know that all of these examples that I've done so far are examples with tangent, but so long as you keep in mind the SOHCAHTOA, these are all relatively simple equations that you can just do. It doesn't really matter. These are relatively easy ones, but so long as you keep getting your practice in, you should be able to get them done. Okay, so let's move on to section 2, using the law of sines. So what we have here is triangle A, and we have these angles 23 and 75. What I like to do is find that last remaining angle. So we add these together, we have 98. So we know that 180 minus 98 is equal to 82 degrees. So that's the last remaining angle, which is always really nice if you're doing a law of sines problem, to just figure out what that last degree is if you're already given the first two. So just doing that really easy test taking solution. And then let's just look at law of sines and follow through on this example. So we have sine, 75 degrees over 14, because we're given this b, these two b's correspond, is equal to sine 23 degrees over x, or let's say a, because that makes everything more consistent. So what we do here is we multiply by a, or yeah, and then we rewrite this equation so that it's turns into A sine 75 degrees over 14 equal to sine of 23 degrees. Then divide this so you've got sine 23 degrees, and you divide that by sine of 75 degrees over 14, this whole thing, and you get an approximation that A is approximately 5.663. Keep in mind it says round to the nearest thousandth, so we just keep that in mind when we do our rounding. Our units are feet, so let's just tack on that too. All right, so let's find that last side. And since we've already found this angle, we'll just do the same process. So we have sine of 75 over 14 is equal to sine of 82 degrees over C. Do this same mess. We'll just simplify it. So we end up with sine of 82 degrees over this mess, which is sine of 75 degrees over 14. And that'll give us C approximately 14.353 feet. So this is a relatively simple law of sines equation, and this next one is relatively the same. Find this last remaining angle. So we have these two combined, which is 153. 180 minus that will give us the last remaining angle, which is 27 degrees. Use that to find A and C. So we have sine 27 degrees over 5 is equal to sine of 52 degrees over A, and is also equal to sine of 101 over C. And this is a degree symbol, not a extra zero. Go through the process like we did last time. We end up with if you follow these steps, you should be able to figure out how to get to these next steps just by following this. I'm just doing an answer right now. So we end up with A being approximately 8.679 meters, and C being approximately 10.811 meters. Since these two examples are the same, I decided not to go fully into depth with this second problem, but this is where things can start getting a little bit tricky. Since for these law of sines equations, we're not told that these are right triangles, we can't assume that, so we can't find this last angle, which means this is a ambiguous case. For the law of sines. So what we'll be doing in this case is just figuring out what our last remaining sides are and just figuring that out. So we know that there are going to be, when we set this equal to sine C over C, we're going to get two possible answers. So we might have to use some other methods to figure out, how to solve that. So we go into sine 34 degrees over 8 is equal to sine of c over 13. This moves us to sine inverse, which is the first time we've used inverse in this entire sheet. So let's might as well do it here. So we multiply both sides by 13. Then we have sine c is equal to 13 sine 34 degrees over 8. And then we do the sine inverse. So c is equal to sine inverse of 13 sine of 34 degrees over 8. Now this gives us two possible results between 0 and 2 pi. However, one of the results is much too large for a triangle. So when we get the other angle, it'll be so large that even adding 34 would not make it a triangle anymore. So sometimes you can just look at an answer. So if you find the sine inverse and it gives you 190 degrees, for example, you can just eliminate that possibility, because as soon as you see that possibility, you can recognize that this cannot make a triangle, because triangles have to have 180 degrees. So we have this sine, and then we can solve this by plugging it into our calculator, and we get c to be approximately 80.675 degrees, also rounding to the nearest thousandth. And now that we have this, we can solve the rest of it fairly simply. Oh, whoops. Sorry, I skipped a step. Plugged in the wrong number. So we find out that this is actually 65.325 degrees, not 80, because 80 is our last remaining angle in this solution. So we have our last angle, which is B. So angle B, now that we have these two angles, is going to be also approximately 80.675 degrees. And now that we have these three angles and two sides, we can solve for the last side using these solutions that we already have, which will give us B as approximately, and if you follow those steps, you'll be able to get it. So we have B is approximately 14.117. And I don't miss any steps in the actual solution. I'm just trying to help you. So I'll be posting an answer key with this, and the answer key won't be skipping any steps. So if you want a more comprehensive answer, then you can look at that as well. So now let's look at the law of cosines. Law of cosines is a little more challenging. Obviously, you want to be able to use the law of sines if you can, because the law of cosines can get a little bit confusing at times. So let's just go through this right now. So we're given two sides and an angle, and from this we can just determine that we can use the law of cosines. So let's just start. A squared equals 13 squared plus 17 squared minus 2 times 13 times 17, cosine of 25 degrees. which is approximately 94.944. So that's what we end up, and this is equal to a squared. So in order to find a, we need to take the square root of both sides, and we find that a is approximately 9.744. And now that we have this, we can find that last angle, also using the law of cosines. So we look at this example. So 13 squared equals 94.944, as we found earlier, right here, because that's a squared. Plus 17 squared minus 2 times 9.744 times 17 cosine of b. And then what this simplifies to is that the cosine inverse of 214.944 over 331.296 is equal to b, which ends up being approximately 0.865 radians. And you can multiply that by 180 over pi to get in degrees, which is approximately 49.549 degrees. Okay, and now that we have two angles, we can solve for that last angle by subtracting these two angles from 180, which will give us the last remaining angle, C, which is approximately 105.451. Now, there are a couple other examples on the worksheet, but in this example, we've gone through law of sines problems, law of cosines problems, and right triangle solutions problems. So just keep reviewing your SOHCAHTOA. Learn how to do the law of sines effectively, learn how to do the law of cosines effectively. And once you have that all figured out, you can, and have that mastered, I'm sure you guys will do great on the test. So that's my worksheet, and I hope that you guys found that helpful. I'll be posting the worksheet itself and the solutions manual onto Canvas as well. So if you're getting stuck, you can look at this video or look at the solutions manual, but I would highly suggest that you try the worksheet on your own. I should have said that at the beginning of the video. Just try the worksheet on your own before you start, and the more practice you get, the better you get at these things, and this can come in handy even in higher level math classes if you're interested in that. And even if you're not going to higher level math classes, it's still a good skill to have. So thanks for watching this video, and have fun learning.